Hello, we are moving along in the class practice for the midterm review. All of these files for files 3, so we see review 3, practice 1, review 3, practice 2, etc. This is basically one long object-oriented program or problem, object-oriented programming problem that is building on itself one step at a time. So I'm actually just going to do all of these in a single video. That'll be probably a little bit longer. What I'd recommend you do is every time I'm at a new file here, just pause the video, see if you can write this out yourself, and then you can skip ahead through the video and see if you did it right or watch specific parts maybe that you didn't understand. And then once I get to the next file, just do the same thing. Just kind of pause and see if you can write it out yourself. So I'm just going to start with this first one. So here we're just going to make a simple class. So make a person class with instance variables of name and hobby, and then add a constructor and a method that returns this kind of string. Okay, so we're going to make a couple of person objects and then run the introduce yourself method on each one of them. Okay, so let's start at the beginning. We're going to make our class, which we do by saying class person. We want to add some instance variables, and the way you do that is by making the constructor or initializer. So we want there to be one for name and hobby. And if you want to be able to pass in the name and hobby when you create the object, you should place them as parameters here. But to make them actually become instance variables, you need to put these parameters inside of self, because self represents the object that we're going to be making. So we do self.name equals name. So this name right here, this is the parameter we're passing in. We're going to put the value stored in this variable inside this new instance variable, right? So self.name is an instance variable. Name is the parameter that gets passed in. Okay, and we do the same thing for hobby. So self.hobby is going to be equal to whatever hobby we pass in there. Then let's actually skip introduce yourself for now. Let's just make the two person objects. Let's just say person1 equals person. So we just say our name of the class like we have here. And when we do this, it's going to automatically call the init function, which means it is expecting us to give it a name and a hobby. So let's just come up with a name, say Jim. Oops, sorry, accidentally ran it. Let's do Jim, and Jim likes basketball. Okay. We have person2 equals a different person object we want to make, and Alice likes... Oh, come on. I keep pushing the wrong shortcut there. Let's do Alice likes finance. Okay, so just as a reminder of what's going on when we create objects here. When I'm trying to create a person object and storing that person object inside of this person1 variable, if I step into this, even though I haven't listed init explicitly, you'll see that when I create a person object, that is a function that just gets automatically called, okay? Then self is the representation of the person object that I want to create, but there's not anything in it yet. There's not any instance variables stored inside of it. We want to run these lines of code inside of init to place the values of the parameters, so Jim and basketball in this case, inside of our object. So if we run this line of code, self, which is our object, is going to get an instance variable called name, and we're placing the value of Jim inside of that variable called name. We do the same thing for hobby, but with basketball. And then once we're out here, person1 is now our person object with basketball and Jim stored inside of it. And we have person2, that will do the same thing. We're just putting different values for name and hobby, right? And we will have that stored there. Okay, so let's write introduce yourself. So whenever a function is placed inside of a class, it's called a method. So whenever you write a method, by default, the very first parameter is going to be a representation of the object that's calling it. And in this case, we don't need any other parameters inside there because we just want to reference the name and the hobby. And those are both stored inside of self, inside the object that's calling it. So we don't need anything else. We can just proceed on with this. And this function is really simple. All we're going to be returning is this little string. So we're going to say, hello, my name is self.name. Let's make sure we put an F in front of there so we can actually make this an F string. And let's make that be self.hobby. Okay. Let's have person1 run introduce yourself. And let's have them print the string that it returns. And we can just do the same thing for person2 as well. So let me set a breakpoint here. We already went over what's going on in these lines of codes where it's creating the person objects. So let me run here. So we have person1. That's our gym person that likes to play basketball. We're going to have them run introduce yourself. And remember, self is our only parameter. And when we're working with objects, the object that calls a method is going to be put in as an argument. So person1 is really an argument inside of our function call. So person1 is going to get put into self up here. So let me step into it. Self has gym and basketball, right? Because person1 is the one that called it, right? So when I say, hello, my name is self.name, I'm getting person1's name and person1's hobby, right? So we're going to return this string back to where we called it, and then we're going to print it out. So we get, hello, my name is Jim, my hobby is basketball. And the same thing repeats once we do this here. So we have person2 is going to call introduce yourself. Going to step inside of there. Person2 called it this time, so person2 is what goes into self. So self, which has hobby and name stored inside of it, can return that. We can print that out as well. So this is a good first example of basic object-oriented programming. We create a class, which is like the template for what we want our objects to look like. We create instance variables that we store inside of any objects that we create. And then we have methods that just allow us to do anything that we want with those variables that we store in the object. So that's our first example there. We are going to now jump to the next example here. I'd recommend reading through this, seeing if you can do this on your own, but I'm going to jump into writing out the solution now. So you'll see here I've already given you some starter code, basically what we coded last time. But we want to make another class called dogPerson that inherits from person. So this whole file is going over inheritance, which is another key object-oriented programming principle that you really need to understand for the midterm. So they have the same instance variables, but dogPerson also has a variable called dog. Okay, so let's just start writing out this new class. And if you want a class to inherit from a parent or superclass, you just add parentheses and you put the class name inside of there. So remember, if you don't do anything, pass does literally nothing. So if we were to do this, and let's say we made person1 equals our person, which is Jim, and Jim that likes basketball. But let's say dog person1, let's say dog person, let's say Alice still likes finance. We'll eventually add dog details to her, but we have done nothing here except say that dog person inherits from person. So when we get to dog person, we're going to look for a dog person init function, but if it's not there, then it just uses what it's inheriting from. So in this case, we're inheriting from person, so we're going to use the regular old person version of the init, of the initializer or the constructor. Okay, so let's step into that. It's actually just going to come up to here, and we're going to give a name and hobby to our object that we're creating. Just notice if we look at self, we are actually making a dog person object, not just a person object. So that's one thing to note there, but it works just fine, just like it did before. So we want to add some extra stuff to it though, because there's no point in doing this if you're not going to actually customize the new class that you're making. So we can get everything that already exists here from the existing class, but we want to add some extra stuff on top of it. So the first thing that we want to add are some instance variables. We want dog to have a string to store a dog name. Okay, so let's just get rid of that and let's do init. In fact, I'm going to let this autofill for me. I'm just going to push the return key or enter key. And what you'll notice is because VS Code recognized that I'm inheriting from person, it's like, oh, you're writing an init function. That means you probably want the name and hobby set up. And then we're going to write super for you. And super just refers to the class that you're inheriting from. So this is saying, hey, call the init function of the person class and give it the name and hobby, just like what we would expect it to. Then after that, we can add any other variables that we want to, that are more specific to our dog person. So let's say we want self.dog to equal dog. Let's pass in an extra parameter for dog here. So let's say Alice has a dog named Spot. So now, when we try to create a dog person, it's going to check if there's an initializer. For dog person, there is, and we just gave a name, hobby, and dog to our initializer. But before we add the extra variables that only dogs have, we are going to run the init function of whatever the superclass is, meaning whatever the parent class is, or whatever class we're inheriting from. So this is basically person.init is what we're referencing right here. And we're going to give it the name and hobby. So we can go down through here. We are going to, in our dog person object, we're going to put a name. So you can see our dog person now has the name of Alice and hobby into there. We're done with that, but now we are also going to add a dog object to our dog person, or a dog instance variable, I should say, not a dog object. Not yet, at least. We'll get there eventually. So you can see we are overriding the original version of this method. Let's see what else we want to do to customize our dog person. Okay, use super to call the person constructor. Okay, that's what we just did. That works. The method introduce yourself should be overridden so that it also says, and my dog's name is dog after the original string. Okay, so if we have introduce yourself, we could, let me show two different ways you could do this. Let's say def introduce yourself. We could just say, hey, we want a new version of this function. So we could just copy the code that's already there and then say, what do we want to add to it? And my dog's name is dog. Say, my dog's name is self.dog. Return that, and let's say we have person one that wants to, let's just start off printing it. Person one can introduce themselves like that. But then dog person one can also introduce themselves. We can print out what it returns. Let's debug our code, right? Person one is a person object, so it's going to use the person version of this as well. When we do a dog person, it's going to check if there's a dog version dog person version of that, right? So if I step into that, that's the version that it's going to use, and we're going to print that out. So we just added some extra functionality on top of it, but we're also repeating code. If you do this on the exam, that's actually totally fine, as long as you get it to work. But it's also nice to think of if there's a little bit more efficient way that you could write something like this. So you could, instead of just repeating that, you could say, hey, how about I run this original version and then just say, I want to run the super version of introduce yourself. And let's add on an extra message to that. So what we're going to do is when we call introduce yourself, we're going to say, hey, run the original version of it. Give me whatever this string is, and then just tack on this extra part to it. So that should work just fine. Let's see if I wrote that correctly. Okay, so I can step into this. It's going to return this string using self, which is still Alice that likes finance. So we're going to get that string here, but then we're just going to add an extra string onto that and then return the combination of them over to here and print that out. So hello, my name is Alice, my hobby is finance, my dog's name is Spot. Let's see, I think that is everything there. Okay, cool. So here we have an example of inheritance. We are inheriting anything that we don't override directly from person, but we can also just reference any of the original versions and add stuff to it, like what we're doing here, rather than repeating our code. So that is an example of inheritance. Let's jump to this next one. Over here. So we are going to do now an example of aggregation. So this is putting an object of one class inside an object of a different class. So I'm actually going to give you basically the same code that we already had here. Okay, I wrote it slightly different to probably make it clearer. But what we want to do here is make a new class that's a dog class. So we have name, breed, and we just have a constructor for a dog. So instead of a dog person's dog variable holding a string, make it hold a dog object. Alter dog person's introduce yourself to say, hello, my name is name, my hobby is hobby, and my breed's name is dog name. Make a dog person, and then run introduce yourself on that dog person and print out the result. Okay, so let's go ahead and make a dog class. So let's make a dog. Let's define the constructor. Dogs have a name and a breed. So let's do self.name equals name, and dogs also have a breed, so let's give it a breed. Okay, then let's see, what did we want to do here? Hold the dog object. Okay, so dog, before we just had this hold a string, now we want dog or self.dog should hold a dog object. So instead of just saying what the dog's name is, because before it was just a string with the dog's name in there, we want to say in my dog, I want here to say in my self.dog.breed, because this is going to be a dog object. Name is self.dog.name. If this doesn't make very much sense yet, we are referencing this self.dog, which is then going to have a reference to a name and a breed. That's where I'm pulling it from, but we haven't actually made the objects yet. So let me go ahead and make those objects, and then we can step through it and see what's going on there. So let's say dog1 is a dog named Spot, and Spot is a Dalmatian. Then dog person 1 is going to be a dog person. And let's say Alice likes finance. And their dog is going to be dog 1. Then dog person 1 is going to call introduce yourself. We're going to print out the string that it returns. Let me go over to here. So at this point, when we make a dog, we have a dog object stored inside this variable. We have a breed and a name, okay? We're passing this entire object inside of dog person. So when we step into here, we're going to give them the name and the hobby, just like we saw before. But now self.dog, instead of just storing a string, stores an entire dog object inside of it. Okay, so even if I hover over this, you'll see you have name, hobby, but for dog, it's an entire dog object. I can click this little arrow here, and I can see any of the instance variables of that dog object stored inside. Okay, so when we run introduce yourself, I can get the original message that we're going to inherit. Hello, my name is Alice, my hobby is finance. Then I want to add this extra message, and I want to get the dog's breed. Well, inside of self, I have a dog object. To get access to that, I just do .dog. That gives me the dog object, and the dog object has instance variables of name and breed. So to get access to breed, I just do another dot, and that gives me the dog's breed that is stored within inside this dog person, Alice in this case. So I can do that for breed as well as for the dog's name. So let's print it out. Name is Alice, my hobby is finance, and my Dalmatian's name is Spot. Awesome. So the idea here is just to remember that if you put an object inside another object, you just have to access that object with a dot here. And then if you want to get access to anything inside of that object, in this case the dog object, you just do another dot. So that's the key thing to remember. Just remember what you named your instance variable that's holding the object. If you want to get anything out of it, you just put an extra dot after that. Then you get access to any of this stuff. Okay. Okay, so that was an example of objects as instance variables. Let's do a slight variation of that. So we're going to have the same thing here, but I think we're going to change this to instead have a list of dogs. So let's see here. Yeah, so do the same, but now dog person's dog variable should be dog list, which should initially be an empty list. So let's just do that right now. Dog list, and we are just going to set it equal to an empty list. If you see something like this on the exam, do not do something like this. Don't set a default value for a list or a dictionary or any data type inside the parameter list up here. That'll cause bugs actually. If you want the default value to just be an empty list, just do it like this. You can look that up. You can ask ChatGPT why. I won't go into the details here. That the gist of it is that it'll make one list across every single one of your objects that you create rather than a different list for each object. But if you need to make a list for any objects like this, I just recommend just setting it equal to an empty list right here. Even if you don't quite understand why, I just recommend that. It'll avoid you running into some bugs in the long run. So let's see, that was the first thing it said. Let me see what else it says here. Alter dog to include a method called dog_info that returns name, breed. Okay, so let's do that. Def dog_info, and this is just a real simple one that just returns some info. So self dot let's say name and breed. I can make it. Let me make it a little clearer what we're going to be printing out. Let's do name, comma, breed, reference the breed. Okay. Alter dog persons, introduce yourself. If they have at least one dog, say, hello, my name is name and my hobby, and these are my dogs. Then run dog info on each of their dogs. It should return a string with the first sentence and all the dog info sentences. If they have no dogs, return hello, my name is my hobby's hobby. We don't have a dog yet. Okay, add 3 dogs to the list. Okay, we have a little typo here. We gotta fix that. Okay, so we're gonna make a dog person and 3 dogs, and we're gonna add those dogs to their dog list. So this is really similar to what we did before. We're just adding another data structure before we get to the actual dog objects. That's really the only thing that's different going on here. So, I actually already created 3 dogs just to save us time, so that's nice. Let's jump then to creating a dog person. Dog person 1 equals dog person. Oops. So let's give them a name and a hobby. Alice really loves finance. And we're going to have dog person 1 has a dog list. And you might think, hey, when did I actually create this? Let me fix Alice's name. And we created it when we created a dog person. Because if you remember, if I step into here, we're calling the init, which is going to add the name and hobby to self. And even though we didn't pass in anything, we are still creating an instance variable and setting it equal to an empty list. So when we get to this point where we have a dog person, they have all 3 of those instance variables, including dog list. There's just nothing in it yet. So let's add a few dogs here. Let's add dog 1. Let's add dog 2, dog 3, there. And then when we introduce ourselves, we want to edit this message essentially to allow us to include the info about the dogs that we are wanting to print out. So let's see, what is this message we want to print out? Hello, my name is Name. These are my dogs. Okay. Actually, let's just not return our message yet. Let's say message and these are my dogs. I'm going to put that on a new line. Actually, I might do the new line down here. So basically, I want to see every dog that's in my list. And for every dog, I want to add a new line that displays their dog info on there. Okay. So I could just loop through this. So for dog object in my self.dog list, because I stored my dog list inside of self, the only way I can get access to it is getting it out of self. Okay, so we do that. Then let's add something to our message. Let's say message plus equals. Let's see, let's have it tab over, and then let's reference our dog object, which, for example, we are appending dogs into our dog list. So like the first one is going to be dog 1, so Max the Golden Retriever. So Max the Golden Retriever is what we're going to reference first in this dog object. Dog objects have a dog info method, okay? So we can just do dot and get access to any method that they run. That's going to return their name and breed. And let's add some space before then. Oops, accidentally deleted that. Let's do a new line, then a new tab, then we're going to tab over right there. Okay, then I think that can get rid of that. Once we are done with adding to our message, let's just return our message. So let's see if I wrote this correct. I might have to fix something in here, but we'll see when I run it. Let's have dog person introduce themselves. Let's print out the message that it returns. So if we run our code, we're going to get a dog person. their dog list is going to be empty, but we're going to append it because we can just do that with any list, and we're going to append an entire dog object inside of their list. So after this, dog person 1 should have their dog list, which has 3 dog objects inside of it, and for any one of those, we can see that they have their own values for their instance variables. So let's step into this one then. Step into introduce yourself. Okay, we're going to run the original introduce yourself to get the first part of the message. So it says, hello, my name is Alice. My hobby is finance. We're going to add, and these are my dogs to it. So now message should say that these are my dogs, okay? Because plus equals just keeps what's there and adds to it. Then we should be looping through our dog list, which has 3 dog objects in it. And we are going to take each one of these out of the list one at a time and place them inside of dog object. So in our first iteration of that, dog object is our golden retriever named Max. So Max is going to run his dog info. We're going to jump to the method in this class. We're going to get the name and breed of Max and just return that. We're going to append it to the message along with a new line and a tab. That's what's going on with the escape sequences there. So we're just going to do that for each one of these dogs until we get to here, and our message should have included all of that, and then we can print it out. So, hello, my name is Alice, my hobby is finance, and these are my dogs. Okay. So she has a lot of dogs. I think the other thing it said to is just have an option for if they don't have any dogs. So we could just add that really quick. Let's do this. Let's say if length of self dot dog list is above 0, or we could even just say if self dot dog list. That would check if anything's in there. That would work too. But we could do this, keep that logic that we just wrote. Otherwise, we want to return the message plus this extra message here. So let's actually run this before we add any dogs. Step into that. So we're going to introduce ourselves, but this is when our dog list doesn't have anything in it, right? Dog list is empty. Its length is 0. So we're going to go over here and we're going to return a message and just say, but they don't have a dog yet. But they're going to get some dogs and they introduce themselves and it functions differently. So there we go. This is an example of putting objects of one class, like dog, inside objects of another class, like dog person, and storing them inside of a data type, like a list. So there we go there. We're almost at the end, actually. We just have a couple more. So one thing it might ask you to do on the exam is to make one of your variables in your class private. So the key thing to remember is that if you want to make a variable private, you no longer have access to that variable outside of the class, as well as you don't have access to it in any subclasses that inherit from that class. To make a variable private, let's see, we already have a lot written for us. Let's see, to make something private, you just add 2 underscores to it, so right here. That means I'm going to have to change the variable when I reference it over here. To save myself time, I'm actually just going to highlight it. And in Visual Studio Code, if you hold the function key and then push F2, it pops up with that screen. That lets you rename a variable. And then anywhere that variable is referenced, it also just renames it which is really nice. So key thing here is that because we just made this private, this code isn't going to work if I try and run this. Let's say we have dog person, and I want to like reference their hobby. Let's say I wanted to print that out. Just a breakpoint in there. This is going to work just fine because hobby is not a private variable. It doesn't have the 2 underscores before it. So if you run that, works just fine, okay? But if we try and do this with our dog list, there's nothing inside of it yet, but we should still be able to theoretically print out an empty list. But when we try to do this, because we made it private, we don't have access to it. It's saying, hey, we don't have an attribute called dog list. So we need to refactor our code so that we are only adding dogs to it through some kind of logic contained within our class. In this specific example, there might not be a super great reason to make dog list private. It's more just to practice this principle while keeping with the same example of dog person and dog. But the whole idea is that maybe you don't want to give the freedom to alter a variable outside of the class. So making something private prevents that potential error from occurring. That's the whole idea of it. And let's see what the rest of the instructions say and how we can circumvent this problem. Okay, so we're going to add a method to dog person called addDog that will append a dog to the dog list variable. Okay, so because we can't access this directly to add dogs to it, we need to add some kind of setter method. So setter method for a private variable just means a way to change or update the value of that variable. Okay, so we are going to write a method called addDog, self and dog object. What we want to do is just update our dog list with the dog object that we're going to append to it. So it's like what we were doing before outside, but because it's private, we can only now do it on the inside of our class. That's the whole idea going on here. So this didn't work before, but now we should be able to reference addDog. And we can pass a dog object inside of there. Let's see. Okay, yeah, that's all we need to do here. So let's step into this code right here. Let's go down there. Let's step into this. Dog person is going to reference self, which has their dog list, and the dog object, okay? And since we are in the class right now, when we reference self.doglist, it works. We can actually do that, and it works just fine. And we have that dog added to our dog list. So that's our first dog person. They're going to try introducing themselves. So we're going to check if there's anything in their dog list. There is. There's something inside of there. Even though it's private, because I'm referencing it inside of the class, it works just fine. Return that, and that works just fine. Dog person 2 doesn't have any dogs yet. So, cool. So that is private variables. Just remember to make a variable private, add the 2 underscores, and then if you want to change that variable from the global scope, you just need to add a setter method, which is just a method called whatever you want that can update it. And if you want to see the results of it, you need a getter method, which is sort of like what this is doing. This is printing out everything inside of this list, or a version of it through the dog info method. But we're accessing it here. We are updating it here. That's the idea. And that brings us to our last example, really, of this review is we have everything that we've basically already done. We have our private dog list, we have dogs and everything here. So we're given a person and 2 dog person objects. Put them all into a list, loop through the list, and print out the result of their introduce yourself method. Make sure that when a person object runs introduce yourself, it does the person version, and when a dog person object runs it, it does their customized version. Okay? So all this code, we've already written it out. So you have a dog person that has dogs, second dog person, and we have person here. What I'm going to do here now is just make a person list. We could just make it a blank list and then append these objects to it afterwards, right? That would work just fine. We could append dog person into there. But since I'm just hard coding this right now, I am just gonna put in. Let's just put in. How about we mix it up? Let's do dog person. Then we'll do a regular person. That's this person object that we're making here, and then we have dog person too. Okay. So notice that I'm putting 2 different types into this list. We have dog person and person mixed in together. What we're going to do is loop through this, say for person object, that might be a dog person or regular person, and person list. We have person objects. We're going to have them call introduce yourself and print out the result of it. Okay, so inside of person list, we have each one of these objects. We are going to step through each one of these, and it might be a dog person or it might be a person. You can put them in the same list. And what's cool is that we're referencing the same, with one line of code that we're not changing, we're actually referencing 2 different introduce yourself methods. If person object is a dog person, and we say, hey, introduce yourself, it automatically knows to use this version of it, which accounts for all the dogs that they have stored inside of their dog list, right? So it's going to run through that. It's going to print that out. This dog person only has a single dog in there, so it just prints out once. But we get to the next person in the list, and they're a regular person. So when we do person object, we put that regular person object inside of this variable that I also called person object, and we run introduce yourself. It automatically does the original introduce yourself method, the first one that we wrote a while ago now at this point. It's going to print that out. Okay, so we got that. That works just fine. And then we're back to a dog person, so it's going to run their version of that code as well. So perfect. So this is an example of putting objects that you are creating inside of some kind of data structure. You could use a dictionary as well, same kind of idea there. And as you rotate through them, if you call a method that exists in both classes, it will automatically call the right version of that. That's called polymorphism, is the technical term for that. But you don't need to know that term for the midterm. You should just know how to put objects in lists and interact with them. That's the main point of this file. So that was the multi-step version of object-oriented programming. If you can understand everything going on in this example here by the end, you should be in a pretty good shape for your midterm, honestly, because we have classes, we have instance variables that we add through using the constructor or the initializer. You can add any extra methods that you have. You reference any instance variables through self. You can inherit from a class. So you have a super or parent class that passes on its data or its structure to the child or the subclass. When a child or subclass wants to reference its parent or superclass, it just uses super, and then it can call what you do here. If you use super, you don't have to reference self, it just automatically passes self in, so that works just fine. To make something private, you use 2 underscores. That means you can only access that private variable inside of the specific class where you make it. You have to add extra functionality if you want to interact with that variable, like add dog, what we did here. And you can create objects of one type and stick them into objects of a different class, like what we've done here. And you can have objects of parent and child classes in the same list, and as long as they both have a version of that method that you're referencing, it'll just work no matter what type of object is actually being stored inside and referenced in your loop. So that is the end of this. If I were in class, I'd probably ask any questions and maybe go over them. And if you want, on your own time, you can look through any past questions that some students have asked. Feel free to just scroll through that. Those aren't any particularly handcrafted examples. That's just past questions that I've answered before. So, like always, just let me know if you have any questions. You can email me or message me on Slack. But hopefully that gives you a good idea of what are the most important things to focus on for the midterm. So, see ya.